Alright, welcome to a video on how to find the area of a regular polygon, area of circles, and how to find the circumference of a circle. Now with our other area formulas and videos, the circles are going to be a little bit familiar to you. You've seen them before, but you may not have seen the regular polygons before, and I may do this a little bit different than you're used to. There are many ways to find the area of a regular polygon. I've tried many ways as I've progressed here with students, and they've struggled, so we're going to try a new way this year. Let's see if this helps you figure it out a little better. So, regular polygon breakdown. A polygon is regular, meaning that it's an equilateral polygon. So all the sides are congruent. So we have our square or our rhombus over there. It's got its 4 equal sides. We have our triangle here, and then we have our pentagon here with its 5 sides, and they're all congruent. So every single one of these polygons is going to have all congruent sides, which gives us an interesting thing when we try to break it down. So here, triangles are friends, not food. The apothem is the perpendicular distance from the center of your polygon to the side. So as you see here in our first square, the apothem goes from the dead center of our square, and it makes a perpendicular line with our side. What that allows us to do is to break apart this polygon into triangles. The most simple shape to break something down into is a triangle. If you think about video games and things like that, that's actually what they do. If you play like old school video games, the 3D video games, you'll notice that they look kind of triangular, the shapes, before they got better and better at it, and they started making smaller and smaller triangles. So that's what they're actually doing here. They're taking these things and they're breaking it down, they're forming it so that it creates new shapes. And that's what we're going to do here. So I'm going to take this square right here, and what I'm going to do is I'm going to separate it into triangles. So I'm going to take this center, and I'm going to go just like that. And then I'm going to go here, and then I'm going to go here. And what that creates for us is we now have 4 equilateral triangles. These are all equilateral. So we've actually just taken our regular polygon. Darn. I don't know why I said that. They're not equilateral. They're all congruent triangles. Gotta stop making these videos so early in the morning before I'm awake. Sorry. They're 4 congruent triangles. They're not equilateral. They're 4 congruent triangles. So triangle 1 is congruent to triangle 2, which is congruent to triangle 3, which is congruent to triangle 4. So all 4 of those triangles are congruent, which is a big help when we're trying to find these areas. So here's our formula that we're going to use. It's going to be n times 1/2 times the area times the apothem times the base. So this 1/2 times apothem times base, here's where that comes from. We take that triangle that we separated, there's our apothem, here's our base. Well, the apothem is technically the height of our triangle. So here our A equals the height that you would see in a normal formula. So this formula right here is actually just your triangle area of 1/2 times height times base, base times height, whichever way you want to put it. So what we've done is we've now just taken something old, something that we knew what we were doing, and we've added a little twist to help us solve a more complicated problem. Now this n stands for the number of triangles. What you could do is you could find the area of one triangle and add it with the area of another triangle and then add it over and over and over. But this actually saves us time, because we know that all these triangles are congruent. Therefore, all their areas are going to be equal. So we can just multiply the number of triangles we have times the area of one. So we look here at our hexagon. We're going to separate it into triangles. I suggest you do this every time. Write it out. Separate it. So we have 6 triangles. 1, 2, 3, 4, 5, 6 triangles. So we know that our n is going to equal 6. Our apothem, which is going to be the height of our triangles, is 4. We see that, and in the center of our polygon. And then the last thing we need is the base. Now all these are equal, and looks like right here it is 5. So now all we get to do is take this formula, A equals n times 1/2 times apothem times base, and plug in the numbers. So A equals 6 times 1/2 times 4 times 5. And we see that the area of this is 60, and since there's no units, we'll just put units squared. Okay, so that's how we're going to find the area of our regular polygons. What I want you to do now is I want you to pause the video and try this on your own. So go ahead, pause the video and do that now. Alright, so here are those worked out solutions to the video. Check your work with mine, make sure we both did it right. I know the one on the right was a little weird because it was a triangle, and then we had triangles inside of triangles. And if you look, you actually here, if you notice, there's right. So here we have the big triangle, then we have the little triangles, and then we have the even teeny tinier triangles that we can make. So we got triangles inside triangles inside triangles. It's like triangle inception here. Okay, circles. So in a circle, the radius, which is represented by r, this thing right here, is the distance from the center of the circle to the edge of a circle. The radius is equal throughout the circle. The diameter is the distance from one edge of the circle to the other that goes through the center. Now, if you cut the diameter in half, you're going to get the radius, and if you multiply the radius by 2, you will get the diameter. We're going to have to use pi here, and pi does not equal 3.14. Do not do that. Use the pi button on the calculator. Okay, we're trying to get into better rounding, so we want to use our pi button. So our two formulas are circumference, which is c equals 2 times pi times radius, and then area, which equals a times pi, the a equals pi times radius squared. So let's jump in and do some examples. I'm going to do the one on the left. I want you to do the one on the right. So we're given the radius here, and we see that the radius is 10. The nice thing about circles is you only really need to know the radius. There's no other dimensions that you need to know, just that radius. So to find the circumference, that's 2 times pi times the radius. So that's going to be 2 times pi times 10, which would be 20 pi. And then 20 times pi is 62.8. And then we don't have units, so units squared. The area is going to be pi r squared, so that's going to be pi times 10 squared, which is 100 pi, and then 100 times pi is 314.2 units squared. Alright, so I want you to go ahead, pause the video, and work on the second one. Please make a note that that is the diameter, not the radius, so you got to do something to that diameter first. Okay, so there are the solutions to those two problems. Go ahead, check your answers with mine, make sure everything's good. After that, you are done with this video.